In the dim light of an ancient Egyptian tomb, archaeologists discovered something unexpected alongside the gold and artifacts sealed jars of beeswax, still preserved after thousands of years. These weren't decorative objects. They were tools, medicine, protection. The Egyptians understood something about this golden substance that modern science is only now beginning to fully explain. Beeswax appears everywhere in human history, and today it's in our hospitals, our skincare products, and even our food. But what makes this material so uniquely useful? What is it about the chemistry and structure of beeswax that has made it indispensable across so many fields? To understand why beeswax works the way it does, we need to understand what it actually is. When honeybees build their hives, they're not using wax they've collected from plants. They're manufacturing it inside their own bodies. Worker bees consume honey, and specialized glands on their abdomen secrete tiny flakes of wax. These flakes are molded by the bees into the familiar hexagonal comb structure. But the wax itself is far more than just construction material. It's a complex mixture of over 300 different compounds, primarily long-chain fatty acids, esters, and hydrocarbons. This chemical composition gives beeswax properties that are rare in nature. It's hydrophobic, meaning it repels water. It's stable at room temperature, but melts at a relatively low heat. And perhaps most importantly, it forms a protective barrier without being toxic or reactive. These properties explain why humans began using beeswax thousands of years ago. In ancient medicine, practitioners didn't have access to synthetic polymers or lab-created compounds. They needed materials from nature that could protect wounds, deliver treatments, and remain stable over time. Beeswax met all those criteria. When applied to skin, it creates a breathable barrier, one that locks in moisture while still allowing oxygen to reach the tissue beneath. This is critical for healing. Researchers have observed that wounds heal more effectively when they maintain a moist environment, but only if that environment doesn't trap bacteria or prevent gas exchange. Beeswax naturally balances these needs. Its slight antibacterial properties, derived from compounds the bees add during production, offer additional protection without the harsh effects of more aggressive antimicrobial agents. In modern medicine, beeswax continues to serve these functions, though the applications have become more sophisticated. It's used as a base in pharmaceutical ointments and salves, particularly for conditions involving dry or damaged skin. Dermatologists have noted its effectiveness in formulations for eczema, psoriasis, and minor burns. The wax doesn't penetrate deeply into the skin it's not designed to. Instead, it sits on the surface, forming a protective layer that prevents further damage and allows the skin's own repair mechanisms to function without interference. This is why it's also used in medical-grade lip balms and treatments for chapped or cracked skin. The barrier it creates is both durable and gentle, two qualities that are difficult to achieve with synthetic alternatives. But beeswax's role extends beyond direct wound care. In pharmaceutical manufacturing, it's used as a coating for pills and tablets. This might seem like a purely aesthetic choice, but it serves several functional purposes. The wax coating controls how quickly a medication dissolves in the digestive system, allowing for timed or sustained release of active ingredients. It also protects sensitive compounds from degradation before they reach the intended site of absorption. Studies suggest that certain vitamins and minerals remain more stable when encapsulated in beeswax compared to synthetic coatings, particularly when exposed to moisture or air during storage. The skincare industry has embraced beeswax for similar reasons, though the goals are slightly different. Here, the focus is less on healing and more on protection and moisture retention. Human skin naturally produces oils that keep it hydrated and flexible, but environmental factors, dry air, wind, sun exposure, harsh soaps strip away these oils faster than the body can replace them. Beeswax addresses this problem without overwhelming the skin's natural processes. When formulated into creams and lotions, it acts as an emulsifier, helping water-based and oil-based ingredients blend into a stable, smooth product. More importantly, it provides that same breathable barrier we see in medical applications. The result is skin that stays hydrated without feeling greasy or suffocated. Cosmetic chemists have also found that beeswax improves the texture and longevity of products. Lipsticks, balms, and salves made with beeswax hold their shape better and resist melting at typical room temperatures. This isn't just convenience, it reflects the wax's molecular structure. The long hydrocarbon chains interlock in a way that creates strength and flexibility simultaneously. This is the same property that allows honeycomb to support the weight of honey and larvae without collapsing, even in the heat of summer inside a hive. Then there's food. This is where the story becomes even more surprising. Beeswax isn't just safe to eat, it's actively used in food production and preservation. The most visible example is on fruit. If you've ever noticed that apples or citrus fruits sometimes have a shiny coating, you're likely looking at a wax layer, and beeswax is one of the substances approved for this purpose. The coating isn't cosmetic. It slows water loss, which keeps produce fresh longer during transport and storage. It also provides a mild barrier against bacteria and fungi, reducing spoilage without the need for chemical preservatives. Researchers have found that wax coatings can extend the shelf life of certain fruits by days or even weeks, which has significant implications for food waste and distribution. Beeswax is also used as a glazing agent in candies and chocolates, giving them a smooth, professional finish while preventing them from sticking together. In chewing gum, it serves as a softener and texture enhancer, contributing to the product's chewiness without breaking down quickly in the mouth. These applications rely on beeswax's status as a generally recognized as safe substance by food safety authorities. Unlike many synthetic additives, beeswax passes through the digestive system largely unchanged. The human body doesn't break it down significantly, which means it doesn't interact with metabolic processes or accumulate in tissues. It simply provides its physical properties, texture, coating, preservation, and then exits. But why does beeswax work so well across such different contexts? The answer lies in its evolutionary purpose. Bees didn't develop wax production for human use. They developed it to create one of the most efficient storage and nursery systems in nature. Honeycomb must be strong enough to hold heavy stores of honey, yet lightweight enough that the hive doesn't become structurally unsound. It must protect developing larvae from pathogens, yet remain breathable so the brood doesn't suffocate. It must withstand temperature fluctuations inside the hive without melting or cracking. Beeswax evolved to meet all these demands, and those same properties happen to align remarkably well with human needs in medicine, skincare, and food preservation. Scientists are still studying the finer details of beeswax's antimicrobial properties. Evidence indicates that certain compounds in the wax, including propolis residues and trace amounts of bee-derived enzymes, contribute to its ability to inhibit bacterial growth. This effect is mild, not strong enough to replace antibiotics or disinfectants, but significant enough to reduce contamination in formulations and coatings. Researchers are also exploring whether different floral sources affect the wax's properties. Bees that forage on specific plants produce wax with slight chemical variations, and early studies suggest these differences might influence texture, melting point, and even antimicrobial strength. This area of research is still developing, but it points to a deeper complexity in what we often think of as a simple, uniform material. What makes beeswax particularly valuable in a modern context is its sustainability profile. It's a renewable resource, produced naturally by bees as part of their life cycle. Harvesting beeswax doesn't harm the colony when done responsibly, and beekeepers who manage hives for honey production often have surplus wax available as a byproduct. Unlike petroleum-based waxes or synthetic polymers, beeswax is biodegradable. It breaks down naturally in the environment without leaving behind microplastics or persistent chemical residues. For industries looking to reduce their environmental footprint, beeswax offers a functional alternative that doesn't sacrifice performance. Yet there are limits to its availability. Global beeswax production is tied to the health and productivity of honeybee populations, which have faced significant challenges in recent decades. Colony losses due to disease, pesticides, and habitat loss mean that beeswax supply can fluctuate. This has driven some industries to explore synthetic substitutes or plant-based waxes, but these alternatives often lack the full range of properties that make beeswax so versatile. Carnauba wax, Candelilla wax and other plant-derived options work well for certain applications, but they don't always match beeswax's balance of texture, barrier function, and safety. The story of beeswax is ultimately a story about specificity. It's not a miracle substance, but it is a remarkably well-suited one. The same chemical structure that allows bees to build secure, stable hives also allows humans to protect skin, stabilize medications, and preserve food. We didn't engineer this material, we discovered it, already perfected by millions of years of evolution. What we've learned to do is recognize where its properties align with our needs and apply it thoughtfully. From ancient Egyptian medicine jars to modern pharmaceutical labs, beeswax has endured not because of tradition, but because it works. And as we continue to understand the finer details of its chemistry and function, that golden substance from the hive remains as relevant now as it was thousands of years ago, a quiet, enduring bridge between the natural world and human innovation.